So this is a recording for the lesson on acid rain. If you can open up the PowerPoint, you will see what we're up to today. Which is to look at the effect of acid on rocks. So first thing you're going to do is find out what acid rain is for me and look at the images below and tell me what's happening in those images. So pause the video now, look up what acid rain is, and then try and link it to these three images. You can answer that stuff here, where it says, what is acid rain? You can answer it there where it's highlighted. So pause the video now and do that. The next bit we're going to look, so hopefully you found out a little bit about what acid rain is. And it's normal rain coming down from clouds just like normal. However, we release gases such as sulfur dioxide, or sulfur, which can form sulfur trioxide. And now those sulfur oxides can join with the rain in this reaction and create sulfuric acid. H2SO4 is the normal version. Sulfuric acid, which is a type of acid, it's aqueous, it's liquid, and it falls down, and that means that the water falling from the sky is not neutral, it is slightly acidic. And that has an effect on things. It has an effect on wildlife, but it also has an effect on rocks and just the ecosystem in general. So what we're going to look at is we're going to look at acid rain and how it reacts with limestone. Limestone is it's calcium carbonate. It's what we used to make lots of buildings out of. It's that white looking statue material that you see. Yeah? So sulfuric acid rain reacts with calcium carbonate, or marble as it's better known, or limestone, and it creates calcium sulfate, carbon dioxide and water. Generically speaking, an acid reacts with a metal carbonate and it forms a metal salt, so calcium sulfate, and carbon dioxide and water. We're going to look at the effect of strength of acid on weathering, or the breakdown of marble. There's two ways of measuring it. You could get the reaction going in a conical flask and feed the gas, and you could measure how much gas is released. Gas released. Terrible handwriting. Alternatively, you could do the same thing. You'd see how much gas is released by looking at the mass decrease, how much the mass goes down by. You've got the mass of the liquid and the chips. They give off a gas which you're then not picking up. So you might start at 70 and go down to like 65 grams, meaning you've lost 5 grams. And that 5 grams is now floating around in the air above it as carbon dioxide, as seen in this formula. So that's what we're going to do. We're going to go for experiment style number 2, and you can go to your OneNote and you can complete some gaps up here, look, for how that happens. I've already done your formula for you. And then I've set up here the images here and the results table, and I've pre-put in our strength of acid I'm going to do. So now it should, you first off think, before you do it, the mass is going to go down because we know carbon dioxide is going to be released, but which one will drop down by the most, do you think, and which one will drop down by the least? What do you think? Once you've finished thinking, pause the video now, have a think. Okay, and then hopefully the video will cut nice and smoothly into the video I took earlier in 2 parts, because I forgot that I had to give up my room, where we see this reaction taking place. Okay, this is our experiment. We are going to first off wear goggles because we are dealing with very strong hydrochloric acid. What we're going to do is we're going to react hydrochloric acid, HCl, hydrochloric acid, of different strengths, so 2.5 molar, 1.5 molar, and 0.5 molar. We're going to react it with what we call marble chips, calcium carbonate, marble chips. I have selected the small chips. That allows my reaction to happen faster. Does anyone think they know why? Have a think for a second. It's to do with the surface area. If you have a large chip, if you imagine this has got an edge around it, if I chopped it in half, it would have an extra 2 edges where I chopped it in half, which would mean it had a larger surface area, so more space for the acid to react with the chips. So that's why small chips react faster. So my first job is I want to measure out the same amount of marble chips for my 3 different experiments. That's going to be one of my control variables. So I'm just going to place on a beaker and zero it, and then we are going to attempt to have 5 grams. Let's just see how much 5 grams looks like. We're going to have 10 grams, that's nearly 8, and that looks pretty much right. Way too much. Swab it out. We're looking at 13 to pour out some chips. 10.97. 9.88. Let's add a small one. 10.03. It's not going to get much better than that. 10.03. 3. I'll pour them into my hand actually. .00. Again, doesn't get much better than that. Although, did I zero the container? Oh, they're about the same. Go with that. Just load in. 4. Missed. Lost a bit. 6. 3. A bit more. 9.7. 10.1. So we can take a tiny bit out. 9.98. 10.01, perfect. So they are all approximately 10 grams of marble chips. Okay, I'm not sure if I managed to edit this or not, but I had a quick location change. What we have in this measuring cylinder here is 30, it's hard to see from the angle, but 30 millilitres of 0.5 molar hydrochloric acid, and we have a conical flask here, so I'm going to add, and I've written on this conical flask, I've written on this conical flask 0.5 so that we know that this is the 0.5, and then what we're going to do is we are going to weigh everything separate, so put the chips So 30 millilitres, and it's 149.82. Yeah, 149.82 millilitres. So I'll just write that on. 149.82. So on the side of the beaker it says 149.82 with 0.5 molar. So what we will do is combine the marble chips with the hydrochloric acid. You can see that reaction taking place and that gas being released. We'll put that to one side until it's finished. 1 minute and 39 seconds on the video. Then I will do the same with the the 1.5 molar. So now I have 1.5 molar measuring cylinder. I'm going to measure out 30 again. Sit it down, twist it round so I can see it, so you can see it. Perfect. 30 ml of 1.5. So we'll have another conical flask labelled 1.5. Put the 30 ml of acid in there. And a marble chips on the scales with it. Keep that marble chip empty container next to it so we know which one was which. This one is 156.92. I'll write that on there. 156.92. So there we have 156.92 for those two. So we'll put those together. See the reaction. You probably notice it's a little bit more vigorous than the previous one. We will put that over there together, leave it going. And notice the first one is starting to finish up its reaction now. And then the last one, we've done the 1.5 molar, put the lid back on. The last one will be 2.5 molar. So we need 30 ml of that. A little bit more care over this one because this 2.5 molar is a good strength, very worthy of care and attention. There we have 2.5, lid straight back on. Okay, sealed up, and pour that into our conical flask. Set that up on the scales. Fluctuating a bit. 183.15, 183.15 we'll call that. So 2.5 M, 183.15. So there we have 2.5 molar, 183.15. Pour in the marble chips. Very quick reaction, you'll see. Probably lots more than the others did. You can see that 0.5 now has finished its reaction. 1.5 is finishing its reaction. 2.5 is on its way, working fast. So we can go back to our 0.5 molar now, and we can re-weigh it. Put it back on our scales. That was 149.82. It's now 149.57. So let's do a quick calculation to find out how much it's gone down by. So, calculator. It was 149.82, and it went down to 149.59 minus 149.59 gives us a reduction of 0.23 grams. So there we go. Move that to one side. It's not quite finished its reaction. No, actually, I think it might be steam on the container. I can still hear it. But that's pretty much finished now. So that was 156.92. So 156.92. Subtract the 156.05 that is now, shows a 0.87 gram loss. 0.87 grams. We can already start to see the pattern emerging that you may have predicted at the start. The 2.5 molar is not finished reacting yet, but let's see where we're at. It was 183.15, it's already at 181.7 and it's dropping. So we've already got 183.15 minus 181.7. We've already got a drop of 1.45 grams. So from our pattern, from our results, we can say that the stronger the acid, the more the loss in mass, the more the marble chips lose mass and give off gas. So linking back to our question, if the acid rain is stronger, then we're going to lose more mass. The statues are going to erode quicker. So you've seen the reaction now. You can fill in your blanks. You can even write a little conclusion to it if you want. But what I'd like you to do is write a description of how you and how just people in general, how society can reduce our contribution to acid rain. What things can we do to reduce how we contribute to acid rain, to just bring all this back together again?